All right, let's dive in. Today we're tackling Wolfgang Pauli. This guy was, well, how do I put this? A unique character in the world of physics.
Definitely unique.
Our source material is a chapter from L. Spin,
Yeah.
a biography of Pauli, focusing on, you guessed it, spin, which, if you're not familiar, is this crazy property of electrons that, well, we'll get into it.
We will. And, it's fascinating how Pauli's personality really impacted his scientific work. I mean, the guy was brilliant, obviously, but also incredibly demanding, always pushing for the highest standards. And then there's that whole thing with lab equipment.
Oh, yeah, the Pauli effect. We have to talk about that. But first, let's set the stage a bit. We're talking early 20th century physics. Think like the Roaring '20s, but for atoms and whatnot.
Right, a time of huge upheaval in physics. It was becoming clear that classical physics just couldn't explain everything, especially at the atomic level. Quantum theory was emerging, and it was turning the world of physics upside down.
And right smack in the middle of this revolution, you have young Pauli. This guy was a straight-up prodigy. Impressed Einstein himself with his understanding of relativity.
Oh, yeah. I mean, we're not talking like high school Einstein here. We're talking Nobel Prize-winning Einstein.
Exactly. And get this, as a student under physicist Arnold Sommerfeld, Pauli wrote an entire encyclopedia article on relativity. And relativity is not exactly a walk in the park, even for, well, geniuses.
No, not at all. It's incredibly complex, and even back then, very few people understood it. But Pauli, even as a student, he just got it.
Okay, so the guy's a genius, we get it. But now for the weird stuff. The Pauli effect. The stories about lab equipment mysteriously breaking down whenever he was around.
Oh, the stories are legendary, like the one about equipment going haywire in James Frank's lab. Turns out, Pauli was in town at the exact same time, even though he wasn't even near the lab.
Spooky action at a distance? Maybe. But beyond the lab equipment chaos, Pauli's real genius was in tackling some of the biggest mysteries in physics.
Right. And one of those big mysteries was the anomalous Zeeman effect.
Okay, break that down for us. Zeeman effect, anomalous, all that.
All right, so think back to high school chemistry class. You know those colorful spectral lines you see when you burn different elements? Those lines represent light emitted by atoms. Now, when you put those atoms in a magnetic field, the lines split further apart. That's the Zeeman effect.
Got it. And the anomalous part.
The anomalous Zeeman effect refers to a specific set of splittings that just didn't make sense based on the existing theories at the time. It was a real head-scratcher for physicists.
So naturally, Pauli had to figure it out.
Of course, he was Pauli, and he did. He proposed that electrons must have an additional quantum number, a hidden property, you could say, with only two possible values. This idea was revolutionary, and it laid the groundwork for what we now call spin.
Pauli exclusion principle time. This one I actually remember from school.
Yeah.
No two electrons in an atom can have the same set of quantum numbers.
Exactly. And this principle had a huge impact. It explained those magic numbers in chemistry, the ones that dictate how electrons fill those shells around an atom. Basically, Pauli's principle is the reason the periodic table works the way it does. It brought order to the chaos.
So we have Pauli laying the foundation for spin and simultaneously revolutionizing our understanding of atoms.
Right.
What happened next in this scientific saga?
Well, this is where things take a bit of a turn. It wasn't actually Pauli who came up with the idea of electron spin as a physical rotation. It was two graduate students, Goudsmit and Uhlenbeck.
Wait, Pauli didn't discover spin.
Not quite. He actually initially resisted the idea, even though his own work had paved the way for it.
So even brilliant minds can be a bit slow on the uptake sometimes, huh?
I guess so. Their advisor, Paul Ehrenfest, knew they were having second thoughts about publishing their spin idea, so he actually submitted their paper for them before they could change their minds.
Bold move.
Right. But he obviously saw the potential in their work. But to answer your question, yes. Pauli eventually came around to the idea of spin. He even played a key role in incorporating it into Schrödinger's wave mechanics.
So another step forward in our understanding of the electron.
Definitely. But there were still challenges ahead, like how to reconcile spin with Einstein's theory of relativity. That turned out to be a really tough one.
Sounds like a job for another brilliant physicist.
Exactly. That task fell to Paul Dirac. But even with all these breakthroughs, there were still mysteries to be solved. And you know who was right there, ready to tackle them?
Let me guess.
Pauli. Yep. One of the biggest puzzles was beta decay. Scientists were observing electrons being emitted from atomic nuclei, but the energy of those electrons just didn't add up. It seemed like some energy was simply vanishing.
That's kind of a big deal in physics. Isn't the whole point that energy can't just disappear?
You'd think so. It was such a problem that even Niels Bohr started questioning whether the fundamental law of energy conservation might be wrong.
Whoa, okay. So what did Pauli do?
Well, maybe out of desperation, maybe a stroke of genius, who knows? He proposed the existence of a new, undetectable particle, the neutrino. This hypothetical particle, he said, was carrying away the missing energy, keeping the law of energy conservation intact.
Wow. So first the exclusion principle, now a brand new particle. Pauli was on a roll.
He was. He really was. And think about this. The neutrino was so elusive, they didn't actually confirm it experimentally until 1956.
Wow. So long after Pauli proposed it.
Yeah, way after. Must have been pretty satisfying for him when it finally happened. But, it wasn't all smooth sailing for Pauli. Not in his science and not in his personal life either.
Oh, what's going on?
Well, seems he had some issues, struggles with alcohol, bouts of depression. He even went to Carl Jung, the famous psychiatrist, for help.
It's a reminder that even these groundbreaking scientists, these geniuses, they're still human, with real problems. What about his relationships with other physicists? Did people even get along with him? I mean, he sounds pretty intense.
He could be, yeah. Sharp wit, super critical mind, not always the easiest guy to collaborate with. The source even calls him the conscience of theoretical physics.
So basically, he was the one everyone went to for a brutally honest opinion.
Pretty much. No sugarcoating with Pauli. He'd dissect your arguments, find every little flaw, make sure you really knew your stuff. But in a way, that made everyone around him better.
I bet those discussions were lively. Any particular collaborations or, rivalries that stand out?
Well, his relationship with Niels Bohr, that was a complicated one. They had a ton of respect for each other, but they also butted heads a lot. Like when Bohr questioned energy conservation during beta decay, remember? Pauli completely disagreed, called Bohr's view completely wrong.
Pauli definitely wasn't afraid to speak his mind, even to someone like Bohr. It shows how seriously he took the science, how important it was to get it right.
Absolutely. He was all about truth and clarity, even if it meant disagreeing with the biggest names in physics. And that attitude, that commitment to getting it right, had a huge impact on how quantum mechanics developed.
So beyond his specific discoveries, like the exclusion principle and the neutrino, how would you sum up Pauli's overall legacy in physics?
Well, it's multifaceted. On one hand, you have the direct contributions, the exclusion principle, the neutrino, his work on spin. These are monumental things, like they completely reshaped our understanding of the universe. But it's more than that. His impact is broader, more like he influenced the whole field.
How so?
He was a catalyst for progress, a mentor to some, a rival to others, but he always pushed everyone around him to be better, to think deeper, to be more rigorous. He just had this way of raising the bar for everyone.
So he shaped not just what we know about physics, but also how physicists think.
Exactly. His influence, it goes beyond any one equation or theory. He represented a certain way of doing science, a commitment to clarity and fearless criticism that still inspires physicists today.
Makes you wonder how physics might have turned out differently without him.
Right. Like imagine the Renaissance without, Da Vinci or Michelangelo.
It's almost impossible to picture.
And, the source even brings up this interesting idea that maybe Pauli's own critical mind, as brilliant as it was, actually held him back from being even more original.
So like maybe a little less rigor, a bit more willingness to just embrace uncertainty could have led to even bigger breakthroughs. Who knows?
That's a really good point. It's like this tension in science between being super rigorous, checking everything, and also having the guts to jump into the unknown, even if you're not sure what you'll find.
Yeah, finding that balance, that's the tricky part. And with quantum mechanics, it's also weird and counterintuitive anyway.
It really is. But that tension, that back and forth between different ways of thinking, that's often where the really interesting discoveries come from.
That's what makes it all so fascinating. It really makes you realize that science, it's not just these cold, hard facts,
Yeah, not at all.
It's a human thing, full of, all the stuff that comes with being human.
Right, the messiness, the contradictions, the whole shebang.
And Pauli's life, it's a perfect example of that. He was this brilliant, groundbreaking scientist, but also, kind of difficult.
Yeah, definitely a complex personality. He was incredibly insightful, saw things others missed, but then he could also be so resistant to new ideas.
And yet those contradictions, it's almost like they fueled his genius.
Yeah.
Like his mind needed that friction, that pushback to spark those breakthroughs.
That's an interesting way to put it. It's true, though, progress often comes from the most unexpected places. Sometimes you have to embrace the mess, the uncertainty, even the frustration to get to something really new.
And let's face it, quantum mechanics, it has a lot of that,
Yeah.
a lot of messiness and uncertainty. And yeah, definitely some frustration.
Oh, absolutely. But that's part of what makes it so fascinating, right? It's this constant challenge to our intuition, to how we think the world works.
Totally. It's like looking into the core of the universe and realizing it operates on rules that just don't make sense to us.
Yeah, it's humbling in a way.
Definitely. And that brings us back to Pauli. He wasn't just a brilliant physicist. He was a pioneer in exploring this strange, counterintuitive world.
Absolutely. His exclusion principle, the neutrino, his work on spin, these are all windows into a deeper level of reality, a reality that operates so differently from what we experience in our everyday lives.
He was always pushing the boundaries of what we thought we knew. Even when he resisted those new ideas, like at first with spin, it's because he held himself and everyone else to these incredibly high standards.
He did. He wasn't going to settle for just any explanation. He wanted something that was not only mathematically sound, but also deeply meaningful, something that revealed a fundamental truth about the universe.
I don't know, it's inspiring, really.
It is. And it's something we can all learn from, whether we're physicists or not. This idea of questioning your assumptions, looking for evidence, demanding clarity, that's important in any field, anything you do.
So as we wrap up our deep dive into the world of Wolfgang Pauli, what's the one thing you want listeners to walk away with?
I think it's this. We need more Paulists in the world. We need more people who aren't afraid to challenge the status quo, to push the limits of knowledge, make us think harder and more critically about the universe and our place in it.
I like that. Well said. And hey, if your computer crashes today or your phone glitches out, maybe, just maybe, it's a little Pauli effect at work. Thanks for joining us for this deep dive into the life and work of Wolfgang Pauli, the brilliant, the exacting, the one and only conscience of theoretical physics.